Hello, we are Petri designers and we are presenting Biocolors. Colors are very important in our daily life. Just take a quick look around. The fabrics from which your clothes are made from could have pigments, and the food industry, where pigments are used as additives. Some fungal pigments can be safe and could easily replace some synthetic ones, since they can achieve identical colors already present. Our main purpose is to produce red, orange, and yellow biopigments in order to achieve the production of oil paints by using natural pigments. Our intention is to avoid the use of synthetic colors, since their production can result in environmental contamination. Biopigments derived from fungi are commonly studied with the purpose of using them in the food industry, but we have decided to explore other applications. We've decided to culture the strain Monascus rubber in yeast extract peptone dextrose. It is important to mention that due to the application of the resulting biopigments, it is necessary to monitor the production of mycotoxins, taking as an example citrinine. This strain was selected because it does provide pigment stability, referring to thermal treatments, sunlight, UV and fluorescent light, pH, organic acid, preservatives, and different temperature treatments for storage purposes.
Methodology. The most accurate method that we can use for the obtention of biopigments is solid-state fermentation, because by following this process rather than going for liquid-state fermentation, biopigments will definitely show more stability regarding common processing and storage treatments. For the solid fermentation process, rice grains must be placed in an Erlenmeyer flask as well as distilled water to adjust the moisture content. Monosodium glutamate and zinc sulfate must be added as well. The next step is to sterilize and carry out the inoculation with a spore suspension. Finally, a period of 15 days of incubation follows, with a temperature of 30 Celsius degrees. After the incubation period has concluded, the content of the flasks will be placed in an aluminum foil sheet, so it can be dried at room temperature for 24 hours. By using an electrical mill, a fine powder will be obtained. The rice powder will be placed in an Erlenmeyer flask with 95% ethanol. After the stirring, centrifugation will follow, and the suspended solids can now be removed. The mixture will be filtered as a last step.
Now, we also want to measure the concentration of biopigments, and in order to do so, a double beam spectrophotometer shall be used. The results obtained will be expressed in absorbance unit per gram of dried solids. Now, with the higher performance liquid chromatography mass spectrometry, the components of each biopigment obtained will be determined based on the molecular weight. Now, for the last step, we've got the oil painting manufacturing. Once we have already got our pigments, the manufacture of the paint must be done. For the final step, there are some materials required. Even though some solvents can be a part of oil manufacturing, they will be eliminated as part of the mixture. The more varnish then will not be included. To obtain functional oil paint, a binder will be needed. Walnut oil is recommended since the use of a stabilizer is no longer needed. A flexible paint is desired because the main intention of using oil paint is to apply it to cotton or linen canvas. The process is relatively simple. It consists in mixing the binder and the pigment to obtain a mixture that can be left to rest. So as a result, we are expecting to obtain semi-solid red, orange, and yellow oil paints that could be used for an artistic purpose. Natural pigments are worth a try in the paint industry, and in order to do so, we are definitely leaving behind all synthetic pigments.